Okay, so I've set up some copper-clad garolite. I believe that's how you say it. It's a 1/16 of an inch thick, and it's single-sided, so I'm not worried about the other side getting scratched. This is just fiberglass. So I'm going to cut some test buttons out so I can test the networking. These are all going to be done one at a time, so I'm going to have to rerun the G-code a few times. Here we go. Okay, there's a button. Well, the circuit for a button. I'm going to cut out a few more, but we're going to go post-process this down. The first thing we do is prime the iron, because that's important that that's ready when we're ready. And we get some acetone, and first we want to clean up the edges. It's important that the paper is able to stick without there being like a lip. Okay, that's pretty good. That one has an edge. Basically just a once over to kind of break all the little ridges that the cutter left over. And I've already sanded down the edges, but it still leaves. You kind of want it sunk on the edges, actually. Not too much, but enough. Okay, so once that's done, then we get serious. I have some 220 grit, and this is to get out like the major defects, like bumps or like deep corrosion and all that stuff. You want to sand it until it's a nice pink color. And I found that sort of like the more kind of grooves and whatnot you put into it with 220 or 320, somewhere in there, the better. You just don't want any really deep pits. You want it to be a consistent surface with a texture on it so it sticks a little bit better. And I typically do more boards than I need. As you'll see in a minute, the toner transfer. I need 2 boards, so I'm assuming one is not going to work because the toner transfer is kind of, it's hit or miss. We're getting better, and there are techniques to make it a little bit more consistent, but usually 1 or 2 boards will be incorrect. Broken traces or, other various problems. So I went ahead and cut, the basic outline of the boards that we're going to etch. I made 6 of them. Like I said, sometimes it just doesn't come out the way that you want it to. Okay, that one still has a ding. Alright, that's pretty good. I'm try and even it out a little bit. At least taper it. Okay, now we do two things. One, oops, throw some acetone on it. Clean it with steel wool. And then another pass with a rag. And you probably want to try doing this with gloves. I mean, safety hazard aside, acetone, blah blah blah, but you don't want the oil from your skin in between, you know, the toner and the copper. So I went ahead, this is a little jig that we made before. Ooh, wow, that's really tight. I wonder if I'll be able to get that out of there. Huh. Alright, I'm going to clean these other ones, maybe one will fit better. Okay. Just a nice acetone bath. I'm probably using way too much acetone, but I don't know. It's the technique that works for me, so this is how I do it. A little more acetone. And this is to get all the little granules of copper, all the little particles that have come off, to get all those off, because you definitely don't want those in between the toner and your copper foil. Let's see if that one will fit. Well, it should. It's a little tight. How about that way? Wow. Okay, how about this one? Okay, that one's a little bit better. I don't remember it being this crazy. Okay. So I'm just going to clean up these edges a little bit. Loosen them up by sub-millimeters. Now you can do this without a jig, but I kind of want what we iron on to be indexed at the location. So now the issue here is, can we make it perfectly straight in there? Or straight enough. Okay, using my hot pink scissors. Oh yeah. You probably don't want to put your fingers on this side either. And you definitely don't want to acetone. Yeah, you don't want to acetone the traces either. So this particular board, should fit right over that board. They're both the same dimensions. So basically what we're going to do is we're going to line them up. We're going to iron them on. Try and get this as close as possible. Doing arts and crafts, alright. That's what I think every time I watch a video of somebody doing this. So my apologies. Okay, so you might be able to see there's a grid pattern here. And I do that so that the water, as you'll see in a moment, has a place to go, and it also gives it more strength. So not only does it allow water in between all these traces, but it also gives it more strength, so that way it's less likely for the traces to be ripped up. So this face down. We'll just try and center it in there. Looks like it's a little too big that way. Now it'd be really cool if there was a robot that did all this for me. It's definitely a thought worth thinking about. Okay, I'm going to cut a little more off to this side. I think last time I cut the lines off, so I'll do that this time as well. Okay, that's much better. So now, just put the iron on to tack it. I realize that it's on acetone. Actually, this is not going to work because this board it's too far down in there. So before we have a spacer underneath it. So what I'm going to do is I'm going to put one side in, leave the other side out, and the side that's out is the side that I'll actually use to get this whole thing started. So just let the iron sit on it for a minute. Okay. Oh wow, that is not straight at all. Okay, well we're going to count that as a maybe win here in a minute. I'm going to work on these other boards, and while we're doing that, since it's already tacked in place, I'm just going to finish it. Or tack the whole thing. And then we'll etch it. Maybe it's recoverable. It's hard to tell because you don't know exactly where everything is until it comes off, but it's definitely not my best work for sure. So I've tried taping it, I've tried a variety of different mechanisms or methods, and this seems to be well, the best. I think I might have overcut the board, so it's a little too big. And I think before we had some foam underneath the board, so I might try that with these. Get some foam laying around. Cutting this one right on the line. So now I'm just going to tack the edge, and I'm holding it with my fingers. It's going to get a little warm, but that's okay. Okay, so that one is much straighter. And we'll set the entire thing up and move on to the next one. And I guess we'll do this one. Keep it orderly. And so since this is the top layer of the circuit board, when you print it, you want to mirror it. That way it comes out right on the top of the board. The bottom, you don't need to mirror. Okay, throw this guy in there. I'm not sure if this one's going to work. There's a big old hole. I guess if I match where that hole is, might work. Okay, so put that in there. So while we're letting this this go, I'm going to go get some hot water in a bucket. The hotter the better. So there's the water. Be careful. You know, electricity, water, you know, all that stuff. Okay, so I like to apply a little bit of pressure, and then a little technique. You let this guy warm up. Okay, and then you pull evenly down the length of the board. And this gets hot, so definitely want to be careful. Okay, I like to do it like that, and then at the corners. I'm applying a little bit of pressure, but I'm holding sort of firmly. Basically, when you do this enough, you can see the traces start to poke out. Oops. Poke out of the side that you're actually ironing. And then we take this, we just throw it in the water. And we continue. I don't know. Maybe it'll come out. I don't know. Ow. I'm not going to try too hard with this one. Throw it in. Okay, now by now, the first one has been completely, well, this particular paper, there's two layers. It's a glossy paper. So what we do, there's an air bubble in there, which kind of scares me. Oh, but look at that, it's not an issue. So the first layer of paper is usually pretty easy. If you try and pull both the layers of paper off at the same time, you'll just rip the traces off. There's just too much tension there, usually. So now we just roll gently at first the inner fibers of the paper off. So we pulled the first layer off. Now we're rolling the fibers off, making sure that you keep dipping it in water so that the bottom layer will completely hydrate, and so that you're not like sandpapering it with other particles. It's very crucial that you're very gentle on the first two passes. And then the last pass, you just kind of scrub back and forth, and you can use a little bit of force on this. I've seen people use toothbrushes. Tried that, and well, it did not work. Did not work the way that I would have hoped. So the idea here is the hotter the water, the better and faster the water can absorb into the paper and create basically like mush. And you want that mush. Okay, so this one is coming out okay. There's a few issues, like this whole area down here kind of got squashed together, so I'm going to have to post-process that. Okay, to another board. And this one is bubbling a little bit, but a little bit less than the previous. You can just kind of rip that off. Okay. And it's kind of a feel thing, you know? Like if you're down to the copper and there's just a little bit of paper left, just scrub on it. Because at that point, you know, the toner is probably going to win, especially if you have this grid pattern. Oh man, this one is beautiful. Came out really good. It came out basically as good as the printout. Wow. I love when that happens. It's really good. I don't see any broken traces or anything. Yeah, that's really nice. Okay. And the sort of failure board, let's see how this one goes. Pull off the first layer. You don't want to pull the first layer from the edge if you can help it. You want to get the paper to split, and then you follow the split and then roll it off. Yeah, see, we lost a lot of... yeah, this one's just kind of a failure. It actually... yeah, this one's no good. No good. That's okay though. We have a way to recover from this. I'm going to get all the paper off before we attempt to recover. Okay. Now I could go etch these two boards while I perform this operation, but I'm just going to keep this all as one segment. Okay, so now to pull the toner off, which is basically the technique that we'll be using later, acetone. Acetone will pull it off, it'll soften it, and then you use acetone to clean it. It comes basically right off. And you'll notice that my finger has touched it now, so I'm going to run it back through steel wool. Okay, there we go. Yeah, that's good. So it's sort of transparent, you can see the traces underneath. That's where you want to be. And then you just apply some pressure to break that first surface, and then you can just roll the top layer off. It comes off pretty easy. And I'm just using some like glossy photo, or photo paper does not work. Some glossy paper from Amazon. Glossy laser jet printer, or laser printer. Laser jet, what is that? Hope I'm not being too... So this is my magnetic stir. Quite proud of it. And the orange. It's an old blender motor. Okay, stop playing around. Ugh. Okay, so we have some cupric chloride. And let's see if I can avoid getting electrocuted. There's a stir bar in there. Okay, so it takes a little bit of effort to get it going. You definitely don't want it to run away from you either. Now what I do is I take a stick. Any old stick will do. And there's a sort of a force coming off of the whirlpool that pins the board to the edge. So I just slide these guys in there. So I'm doing 3 boards, I'll put them in thirds. And there we go. Now we wait. It's been about 30 minutes. Time to check. So it's this board. I'm gonna touch the acid. Oh my god! Just kidding. This board is almost done. It just needs to. You can kind of see the red bits, the orangish red, coppery looking bits. Those need to come off. So I'm gonna flip it over a little bit and pull it back down. And see how the other ones are doing. That one looks about the same, so I'm going to flip it over. And the same. So this is cupric chloride. It is like hydrogen peroxide at 3% mixed with hydrochloric acid, which I believe was 30%. So it's not really acidic, but it definitely burns if you leave it on your skin for a while. And it's laden with copper, so it's probably not good to let it absorb. So I'm going to let this go for, I don't know, maybe another 15 minutes and then pull them out. That's good. That goes in the water to rinse. Okay, that one has a little bit more, I think. Actually, no, it's good. All that's just extra toner on there. Into the water to rinse, and the last one. Looks good as well. Okay. So I'm going to rinse it in water for a while, just let it soak, and then we'll pull the toner off. Okay, so now I'm going to use acetone to pull the toner off. Okay, go over it once with some steel wool to kind of clean up the copper. I'm going to tin all the lines as soon as I can to keep them from corroding, because it will corrode, and it doesn't take much time for that to happen either. Okay, so that's pretty good. Give it a little wipe. Look at that. Beautiful circuit board. So there are places where it's jumping or shorting. I'm going to fix those with a razor. I find that it's, depending on how big the jump is, it's usually easier to fix in the copper, because you can actually score it once lightly, and then I'll show you how that works. And the last board. A little bit more acetone. Go through a lot of acetone. Okay. Wipe that off. Yeah, this one basically has the same problems. I mean, these big pads are jumping. I'll just fix those with the razor. Otherwise, it looks really good. There's a couple spotty ones. You know, honestly, nothing that can't be fixed with some jumper wires or a little more solder. This one, I'm not sure about. All this mess down here, that's probably salvageable if I need to, but I'll probably try to avoid it if possible.